The positive strip on the breadboard is connected to digital pin 7. The negative strip on the breadboard is connected to ground. The positive strip is then jumped to the resistor, goes through the resistor, and then in parallel goes through to analog in 5, as well as the capacitor. Once it goes through the capacitor, it is then jumped to ground.
So here we have the RC circuit simulated response from MATLAB. This blue line here represents the 10 kilo ohm resistor, which reaches its max value of 5 volts in under a second. Then we have this red line here, which represents the 100 kilo ohm resistor, which reaches its max value in just under 6 seconds. So here we have the Arduino code for Lab 5. These things here initiate a bunch of variables, this being the input pin, this being the output pin, this being the resistor value, which obviously gets commented out depending on which one we're using. This is the capacitor value, and then tau, which is the time constant, which is just the resistor value times the capacitor value. Then we also initiate our timers. These timers will be used later. And then finally we have the variables initiation for Vin and V capacitor. Moving on to void setup, we have our pin mode initiation. So we have the input pin, aka the analog 5 pin, as an input, and the output pin, aka digital pin 7, as the output. This part right here sets the output pin or digital pin 7 to 0 volts for 5 seconds so that the capacitor can fully discharge before moving on. And then this just initiates the serial monitor so that way we can communicate with other programs. Moving to void loop, we start with this if statement. This if statement makes it so that the input voltage changes from high to low every 10 time constants. So the way it does that is by taking that timer voltage I initialized earlier and then subtracting the current time from it. Then if that value is greater than 10 times the time constant in microseconds, then it will then switch from either if it's a high to a low or if it's a low to a high, and then it will then increment that timer voltage. So this if statement collects data every 1/50th time constants, and it does this much the same way as the previous one. So it checks the time subtracted from the initialized data timer earlier that I had, and then checks to see if that is greater than the time constant divided by 50, aka 1/50th of a time constant. If it is, then it reads what the current input voltage is for the digital pin 7, and then stores that in a variable Vn. Then it moves on and does the analog read for the input pin at analog 5, and then stores that as the voltage of the capacitor. Then initializes a data string, which we will then add the voltage from digital pin 7, and then a tab, and then the voltage from the capacitor. It then sends that data in a string to the serial monitor, and then increments the data timer. So here we have the serial monitor for the 10 kilo ohm resistor. When the digital pin is switched to on or a 1, it quickly goes up to 1023, and then when it's set to off or a 0, it goes down to 0. So here we have the processing part of Lab 5. So I changed the size of this a little bit to make it a little bigger, a little easier to see. So then this part here sets the background to a lighter gray color, and then gives you all those lines from 0 to 5 volts, also denoting which line is equal to which volt. This part right here is the key that shows you which set of circles is corresponding to which voltage, Vin or V capacitor. Since I edited the size of the window, I had to adjust some of these variables a little bit to make them work a little better, but other than that, this is mostly unchanged. Then this part right here states that once X reaches the far right of the screen, it needs to wrap back around, and so it just goes back through all of that stuff that I had in the setup to give you the lines for the voltage, the change in the background color, and the key, so that way you can always see it. So this is the output of the processing code, the green being the voltage of the capacitor and the red being the voltage inputted. So here we have the MATLAB plotted data from the processing. So as we can see, the 10 kilo ohm resistor reaches its max value in just under a second, it looks like. And then the 100 kilo ohm resistor reaches its max value in what looks to be just over 5 seconds, maybe just under 6 seconds. So that matches up pretty perfectly with the simulated MATLAB data we saw earlier.